Hi, in this video we are going to be talking about how to use the bisection method to solve the roots of an equation. Now when we say we want to find the root of an expression, we are basically trying to find when this curve will actually be touching or crossing the x-axis. Okay, now in order for us to do this, okay, using the bisection method, there are a few steps involved. Okay, so I'm going to list them out one by one. Now step 1, okay, requires us to find, okay, two numbers, okay, a and b, okay, such that the f of a and f of b are or give different signs, okay, give different signs in terms of the answer. Okay, now if I were to try, okay, f1, okay, you can see that the value I'll get is 1 minus 1 minus 1, which is equals to minus 1, and f of 2 will be equals to 64, 2 to the power of 6 minus 2 minus 1, which is equals to 61. Okay, so as you can see, on one side I have a negative number, the other side I have a positive number, which means, okay, that if I were to draw the curve, okay, at the point when x is equals to 1 and the point when x equals to 2, there is a crossover from the negative side of the curve to the positive side of the curve, okay, from 1 to 2. So from negative 1 it goes all the way to 61 over here. Okay, so that is the first step. So from this we can say that your a is equals to 1 and your b is equals to 2. All right, now we can go on to the next step. Okay, so let me move this table down a bit first. Okay, I'll be using that table shortly. Now for our step 2, what we need to do is to compute c. Okay, and c is basically a plus b divided by 2. Okay, so as you can see from the initial values of a and b, you get 1 plus 2 over 2, which is 1.5. Okay, then we have step 3. In step 3, what we have is if b minus c is less than equals to the epsilon, which is the tolerance we are willing to accept, then we say that we are willing to accept c as the root and we can stop. Okay, now if that is not yet the case, okay, that means we still haven't reached the final amount of error tolerance that we can accept, then we need to do one more step, which is to check if f of a and f of c, okay, multiplied is less than equals to 0, then we set c as the new b. Okay, otherwise set c as the new a. Okay, then go back to step 1. Okay, so these are the steps that we need to do. Now let me go through these steps for this question over here, and you can see how we are actually applying these steps to solve the problem. Now to do this question using the bisection method, you need to have a table. All right, so I've already drawn out a table here, and this table, okay, what are the columns? So the first column is the n, which is the iteration, followed by a, b, c, which is what we just saw just now, a plus b divided by 2, okay, and then b minus c, f of c, and f of a. Okay, now let me go through with you step by step, okay, and then you can see how we will arrive at the final answer. Now for the first iteration, we saw that a is 1 and b is 2 and C is 1.5. So the difference between B and C is 0.5. Next is FC. FC means what do? I take the value C over here, okay, and I put it inside the f function. What is the f function? X to the power of 6 minus x minus 1. Okay, so maybe I'll write it over here. That f of x in this case is x to the power of 6 minus x minus 1. So I take the value of C, which is 1.5, and I put it inside. Okay, so I'm just going to show you for one example here. So I'm going to have 1.5 to the power of 6 minus 1.5 minus 1. Okay, so that is for the first iteration here, and that would give me a value of 8.8906. F of A is basically the same f of x, but I put the A inside x. Correct? I substitute x with the value that is in A, which is in this case 1. So 1 minus 1 minus 1, I get minus 1. Okay, so that is the first iteration. And at the end of the first iteration, or every iteration, we must look at step 3, which is to see if B minus C is less than or equal to epsilon. So epsilon is the error we are willing to accept, which is 0.001. Okay, so that is the error we are willing to accept here. Epsilon equals to 0.001. In this case, the B minus C, which is the error, is still very high. So we are not yet anywhere near the end point. So the next step is look here, FA, FC. So f of A multiplied by f of C, is it a positive or negative? It is a negative. Okay, that means this condition has been satisfied. So if this condition has been satisfied, I set C as the new B. Okay, that means C over here as the new B. So I'll get 1.5 here. Okay, A is remains unchanged, so A is still 1, and this is the second iteration, and is 2. Okay, and the new C is B, A plus B divided by 2. So 1 plus 1.5 is 2.5, divided by 2 is 1.25. And now B minus C, I will get a value of 0.25. And now what do? FC, I take 1.25 and put inside this expression here for x. Okay, and I will get an answer of 1.5647. And FA, so since A is unchanged, the current FA will still be the old FA, which is minus 1. Okay, so again we look back at the epsilon. Okay, the error difference between B and C. So B minus C is still not yet smaller than or equal to the epsilon here, so we have to carry on. So when you carry on to step 4, we first check this condition, FA multiplied by FC. As you can see, FA is negative, FC is positive, so negative and positive will give you a negative number, so this condition is satisfied. So set C as the new B. So C will become the new B over here. So 1.25 comes here. Okay, so this is the third iteration. A is still unchanged. Okay, and C is A plus B divided by 2. So I get 1.125 here. Okay, B minus C. Okay, so 1.25 minus 1.125, I'll get 0.125. Okay, and f of C is taking the C value and putting it inside here. I will get a value of negative 0.0977, and here I'll get negative 1. Okay, now again we check if B minus C is less than or equal to the epsilon. Is not yet there, so I have to carry on, and to carry on I look at step 4. So in step 4, if I look at FA multiplied by FC, what I see is FA is negative, FC is negative, so negative and negative is positive. Okay, so when negative and negative is positive, this first condition is not fulfilled. So otherwise, I come to the second condition, which is to set C as the new A. Okay, so the C will now transition to be the new A. So I get 1.125 over here. Okay, so this is the fourth iteration. Okay, and so the A has now changed, but the B will now remain as the previous value, which is 1.25. Okay, and the C is again A plus B divided by 2, so I get 1.1875. Then here I will get B minus C, which is 0.0625 and 0.6167. Okay, that is your FC, and finally your FA you will get as negative 0.0977. Okay, and we look at the B minus C here, 0.0625, again not yet reaching, not yet at the epsilon we want, so we have to carry on. So when we take FA multiplied by FC, in this case it is less than equals to 0, so in that case the first condition is satisfied, so set C as the new B. Okay, so the C over here will become the new B. Okay, so 1.1875 will come here, and the A will be the previous A, 1.125, and this is iteration 5. Okay, and this whole process will keep on repeating. Okay, and I'm going to fill it up now. Okay, and as you can see, once we have hit a certain number of iterations and the error condition has been or the epsilon condition has been fulfilled, we can stop. Okay, so let me fill up the rest of the values now so that you can have a check while you are doing it. So you can see that in the 10th iteration, we have fulfilled the epsilon to be less than equals to 0.001. So we can accept C to be the answer. So this answer C is the root. Okay, 1.1338 is the root for this expression over here, x to the power of 6 minus x minus 1. Okay, and what this video has shown you is how to approach it step by step, okay, using the bisection method. All right, thank you for watching, and I will see you in my next video. Thank you. Bye.